Hi there matriculants and grade 11 learners, and also hello to anyone else that is tuned in. Okay, right, so what I have today is a circle geometry question, or what most of us know as Euclidean geometry. Right, now this video is of interest to you whether you are a grade 11 learner or a matriculant this year. It doesn't really matter. Okay, remember matriculants that in your paper 2 you are going to have grade 11 Euclidean geometry tested, but what gets added to your syllabus is that whole thing about similarity and the proportionality theorem, right? That's all that you really add to circle geometry in grade 12, right? Okay, so without any further ado, let's look at November 2019 question 11. Okay, now with answering any circle geometry question, your first step should always be to read the statement that is given above the diagram, right? So that you get sort of familiar with what is actually in the diagram and start making notes on your actual question paper. Please don't be scared to put any notes down in your question paper, but just a quick recommendation, don't use too much color, as color can be a little bit confusing, and also color is impossible to erase, right? So always start putting down some notes and key things on your diagrams using pencil, right? That is a tip that I would like to give everyone today. In the diagram, O is the center of the circle, right? Passing through points A, B, C, D, and T, right? So they basically, what they're doing now is just naming our circle, okay? That's all that they're doing. They're basically telling us that this circle that we're looking at here has these points A, B, C, D, and T on its circumference, right? Which means that any line, right, that is going to travel from the center, which they said is O, right? Any line that's going to travel from that center, let's actually make it green, right? So long as it's going to travel from the center to any of these points on the circumference, then that line is a radius of the circle, right? So now you can start seeing where all the radii are in this diagram. You also get to see that actually in this diagram, this line segment AT is actually the diameter. Right, and why do we say that AT is the diameter? Well, because it's made up of two radii for one, or by definition, the diameter is the chord of a circle, right, that passes through the center. Okay, that is just by definition. Cool, right. So now let's see what else do they say. They also say to us that HC and HT are tangents, right? So that is very important for us to know. So HC and HT are tangents, right? Can you see that there's a common letter over there? There's a common letter of H, which means that we must draw from our tangent theorem that says that two tangents drawn from an external point outside the circle are equal in length, right? Okay, let's see. Right. We also have the theorem that says that a radius always meets a tangent, right, at a 90-degree angle. And we've already highlighted our radii over here. All these green lines are actually the radius of this circle, right? So we can see already 2 points of tangency here at T and at C. There's not much labeled at T, so you most probably won't even have to use it. But you nonetheless know that the angle over there is 90 degrees, right? That's because a tangent and a radius always meet each other at 90 degrees. You also now know that angle C2 and angle C3 is also 90 degrees. Can you see that you've actually proven, without them even asking you, that CHTO is a cyclic quadrilateral, right? Which means that we could be able to draw a circle around those points, right? So if that comes up, that is definitely the proof that we are going to go for. Okay, now let's see, what else do they say? They also say to us that AD, right, so AD is this line segment over here, right, so this chord AD, right, So AD is produced to meet the tangent HC at R, and you can see that happening over here, right? The chord has been produced to meet that tangent over there. Okay, so now anytime they say to us that something is produced, right, that means that we can look out for an exterior angle. So let's see. Okay, so at this point D, let's try to zoom in here a little bit. Right, so at this point D over here, right, you can see what you have there is this angle D3, right, and then it goes and touches this chord over here, CD, right, which is actually part of this triangle. So which means that angle D is the exterior angle of, angle D3 is the exterior angle of this triangle. It would equal angle C2 plus angle J3, right. If we need it, we will refer to it. Right, so let's read on. What else do they say? They also say that OC, right, so OC is this radius over here, bisects, right, bisects. Remember this word bisects, right, means to divide into two equal parts, right? That's what the word means. Right, so something else that we know is now that AJ, right, the length from A to J is equal to the length J to D, right, so J to D. And that's basically given, right, we know that. We're just going to put it right next to the diagram so that if we need it, we can use it. Right, what else do we have over here? Well, I see something that is sticking out quite a lot, right, and this is this angles in the same segment over here, right, angle B being equal to angle C1 plus angle C2, right, those angles are coming from the chord AD and it's subtending angle C1 plus angle C2 and angle B at the circumference, right. So if we also need that, we will use it. And then lastly, they say let angle C3 equal X. Right, now for the questions. Right, question 11.1 says, write down with a reason, right, or it's just a reason, right, another angle equal to angle C3, right, so angle 11.1, right, so angle C3, like we mentioned, is this angle here between the tangent and this chord CD, right? So now if we check, angle CD goes to the circumference and it subtends angle B2, right? So which means by the tan chord theorem, since that is an angle between the tangent HC and the chord, right, that's now equal to the angle in the alternate segment. It means that by the tan chord theorem, right, our other angle that's equal to angle C3 is angle A2, right? So we're going to say angle A2 is equal to angle C3, and that's simply by the tan chord theorem. Perfect. Right, next question. Question 11.2 then says, show that CHRJ is a trapezium. Right, so CHRJ is this figure over here. Right, so we just need to show that that figure is a trapezium, which means all that we need to do is to show, remember a trapezium is just a quadrilateral that has at least one pair of opposite sides parallel, right? That is a trapezium. So if we can just show, right, that one pair of opposite sides is parallel in this figure, then we have shown that it is a trapezium, right? Let's remember, how do we get our parallel lines? Well, we can look for our corresponding angles, we can look for co-interior angles, or we can look for alternate angles, right? In other words, we look for this fund. Any of these options proves parallel lines, so we just need to figure out which one can we use, right? This is still early on in the question, so it should be quite obvious, right? Okay, so I can already see that I have this angle of 90 degrees here at this point of tangency, right over here. Sorry about that. Right, so over here we have this angle of 90 degrees, and we said that angle of 90 degrees came about because the radius is perpendicular to the tangent. Right, so now if we try to see, maybe we can use co-interior angles by proving that this angle here, angle J4, is also 90 degrees, and that is actually true, right? Why is this true? Well, because we have a line, right? This line over here, OJ. This is a line drawn from the center of the circle to the midpoint, right, of this chord. How do I know that J is the midpoint of the chord? Well, I was told that OC bisects this chord AD, right, which makes J, right, the midpoint of this chord, right? So if that's the midpoint, then we have the theorem that says that a line drawn from the center of the circle to the midpoint of the chord is perpendicular to the chord. So that places a 90-degree angle over there. In fact, it places a 90-degree angle everywhere at J3, J2, and J1. Right? Okay, so thus we've then proved that HC is parallel to DJ, right, which makes that figure a trapezium, right? So all we need to do now is just write that down, right? Let's see now what else. Question 11.3, right? It says prove that OC bisects ACD, right? So we need to go back up and figure out what is ACD, right? So ACD. All right, ACD is this angle C1 plus angle C2, right? So all we need to prove is that angle C1 is equal to angle C2, so that we can prove that OC not only bisects this chord AD, but also bisects the angle ACD, right? This is actually already proven for us, right? Simply by congruency. You can see here you've got this common side, right? This length CJ, right? It's a common side. You also have that in each of these triangles you've got 90-degree angles, right? So you have angle J2 and J3 equal to 90 degrees, right? And you also have that this side lengths are equal. So by side angle side, and it is side angle side, please people, because I'm going to try to make this like this. So it's a side, this side over here, that angle, and in this side again, right, is what you are using to prove this congruency. Please do not use right angle hypotenuse side, because you did not prove the hypotenuse of these two right angle triangles equal. Okay, right, so let's just write that down and just basically check that the angles are actually equal. So in the first triangle, this is actually angle C1, and then this is angle J2. This is then angle A2. I'm going to move these numbers now. So then in the second triangle, the corresponding angle to angle J1, if you imagine flipping or folding these two triangles on this line CJ, right, then the angles that should fold over each other or onto each other exactly, for angle C1 has to be angle C2, and then for angle J2 it has to be angle J3, and then for angle A2 it has to be angle D1 plus D2. Okay, I can't write 1 and 2 here, but I can see that basically the order of my letters is absolutely correct. Right, what is missing here? It's just my reason, side, angle, side. Okay, so now because these two triangles are congruent, it therefore means that angle C1 is equal to angle C2, and the reason for this is the actual congruency. So you rewrite it Please do not leave out this step over here. You can also write the reason. You can just say congruent triangles, right? You can do that as well. But you have to write some sort of a reason as to why that is the case. Okay. All right. So if angle C1 is equal to angle C2, and angle C1 and C2 is this angle ABC, right? So therefore, I've now proven, okay, so therefore, I've proven that OC bisects ACD, right? Because what it does is that it makes angle C1 to equal angle C2. Reasonable enough. Right, so what else do we have to do in circle geometry? Well, we have to keep track of everything that we've proven and anything of that sort by putting it onto the diagram. So what I'm going to do is I'm going to put these two lines here to remind myself now that those two angles are congruent to each other. Remember, the word congruent means equal, yeah? Right. Okay, let's see what else. Question 11.4 says write down with a reason. Okay, sorry about that. So we want a reason as well with this. Why, or write down with a reason A, B, D in terms of X, right? So A, B, D in terms of X. Alright, so ABD is just that angle B over there, right? This angle over here in this pink highlight. We already know that's equal to angle C1 plus angle C2, right? So in terms of X, we would have to connect an X to one of these angles, and angle C2 is part of this 90-degree angle over here. So that 90-degree angle also has part of it, this X. So that's where the X is going to come from. So angle C2 is 90 degrees minus X, right? So which means that twice that is then going to be angle B, right? So let's write that out. Angle ABD is equals to angle AC, ACD, and this is angles in the same segment. Right, you can also add here that they are subtended by the chord AD, right? So they come from, in other words, this chord AD. So therefore, to write down angle ABC, there it is, there is the reason. So we just need to conclude it in terms of X. Angle ABD is 180 degrees minus 2x. Okay. Right, so then our last question is to determine angle R2 in terms of x. Right, so we need to find where angle R2 is. Right, so here is angle R2, this angle over here. Right, so we need to find that angle now in terms of x. Right, so we need to figure out what is this angle connected to. Alright, it is pretty tricky to see, but if we just put the full picture on screen again, right, if you see what angle R2 is touching, it's touching these lines, the tangent HT, right, so which means that it has this line, and what it's also touching is this chord, well, this extended chord AD, right? So in other words, it is an exterior angle to this triangle ART. Can you see that? I hope you can see that. Okay, so this triangle over here, right? Angle R2 is the exterior angle of that triangle, right? So which means it is equal to the sum of the interior opposite angles, which is going to be this angle T, which is 90 degrees, right? Because why did we say that? Radius perpendicular to tangent plus angle, angle A3, sorry. Right, so all we need to figure out is what does angle A3 equal? Right, so let's just finalize a few things here. Right, so basically we already know that this is 90 degrees, right? And can you see here that we've got angle at the center equals 2 times angle at the circumference, right? So this is the angle at the center, angle O1, right? Angle at the center. That angle there is twice the angle at the circumference, right? If you put your hands on a C, you'll see that from A to C, we can also go to angle D1 plus D2. Okay, so this angle at the center is twice the angle at the circumference, right? So which means if we can find what is angle D1 plus D2, which I can already see by alternate angles, right, is equal to angle C3, right? So we have an x over here, so which means this is 2x, so this angle here is 90 degrees minus 2x. Okay, so then angle R2 is 90 degrees minus 2x plus 90 degrees, right? So 90 degrees plus 90 degrees is 180 degrees, so angle R2 is also equal to 180 degrees minus 2x. Okay. Alright, and if you want an example of how you would write out all of those steps, there they are on screen. Okay. Right, so that brings us to the end of this video. Please remember, besides the fact that I used color in this video to actually explain, I still suggest you do not mark anything on your question paper using color, because I have the advantage here to just erase the color off if I make a mistake. You do not have that advantage in a test or an exam to erase a highlighter that you have put down in case maybe, let's say, you have identified the incorrect relationship between angles and you now want to erase it. You will not have that option available for you. So please matriculants or grade 11 learners, please use a pencil, and once you are now confident and able to do your circle geometry questions, you are more than welcome to go ahead and use your color. Right, until next time guys, bye.